In this video, I will show you how to model, analyze and design the strap foundation in the CSI SAFE software. In this example, I will use the previously defined data. For example, define material property 24 megapascal concrete, reinforcement for 20 megapascal, and for the slab properties, I will use footing 300 millimeter and stiff column is also 300 millimeter. Furthermore, I will use the same soil subgrade properties data that is defined in the previous videos. Here, the allowable body pressure 200, allowable settlement is 25 millimeter. The same data and the soil subgrade modulus is 8000 kilonewton per meter square per meter. Okay, and the beam properties here modify. Here is a predefined concrete beam that is 300 by 600 millimeter. Okay, the beam material will be concrete 24 megapascal, rebar material will be 420, and rebar material for shear will also be 420 megapascal. Here all the data for the rectangular beams. So here is the cover top to the centroid, so that is 75 millimeter. That will be okay. Okay, so now here is a grid data define x in the x direction, two grids 1 and 2. The distance between the grids in the x direction is 4 meter. You can check here in the status bar, that is a x0 y0 z0. In the x direction, x is 4, y is 0, z is 0 in meter. Okay, for the drawing of footing, I will click here quick draw footing, and I will draw a 1.5 meter by 1.5 meter footing, and I will click 1 point here and 1 point. Okay, so now I will click the stiff column, that will be 300 millimeter by 300 millimeter. Okay, I will click at the center. Now for the deselection mode, or press escape key. Now I will draw the center point. At the center, draw points here at the center, because I want to click these points and then apply this load. For that purpose, I have drawn the points at the center. Escape. Now I will select the slab, both slabs or both footing slabs, and then go assign spore data soil properties, that is a predefined 200 megapascal 200 kPa divided by 25 millimeter settlement, allowable settlement. Okay, so here you can see soil properties have been defined. Furthermore, for the applying of loads, I will click the center points. Here I will apply, for example, assign load data point loads. For example, I will apply live load of, for example, 120 kilonewton downward. Okay, and for the only left slab, on the right slab, right footing, I will assign load data point loads. For example, now add to existing load, or here I will click 0, and the mx moment may be 33, and the my moment maybe you can take it as 20 kilonewton meter. Okay, now you can also check that these loads have been added to the previously load. Right click at the center, go in the loads. Here you can see the point load and the moments have been applied successfully. Okay, now loading conditions are already defined, all the things have been defined. Just check the load combination here. Service load combination and ultimate load combinations have been defined. Okay, now I will run the analysis and design. Okay, now see display, show deform shape against the service load combination, apply. Here the settlement is maximum settlement is 16 millimeter. Further it is within the limit. For example, if it goes beyond, what will happen or how you can handle by strap foundation. That is a maximum 16 millimeter. So now let's check the soil pressure. How much is the soil pressure? Apply. Okay, so maximum soil pressure is 134 kPa, kilonewton meter square, kilonewton per meter square. So that is again less than 200 kilopascal. So if, for example, in your footing that soil pressure is exceeding or settlement exceeding, and your footing is corner footing, for example, let's make it corner footing. Okay, so here is a calculator, sorry. Okay, so our footing is 1.5 meter. 1.5 divided by 2. Okay, that is 0.75 meter. It's a center. So if we have to move the footing from here to here, I have to minus 0.15 minus 0.15, that is the half of 300 millimeter. Okay, 0.6 meter. So it means I have to move this footing in the left direction. Select this footing and edit, move points or slash areas. Here I want to move in the negative x direction, so that will be minus 0.6. Okay, so here you can see footing, now it's become the corner footing or edge footing. So now let's see what are the results. Display, show deform shape against the load combination, service load combination, apply. So now it's exceeding the allowable limits 28 millimeter. That will be more than 25 millimeter. Second check. So show soil pressure. Okay, against service load combination. Okay. So now the soil pressure is also exceeding the 200 kilopascal. So it means our bearing check and settlement check is failing. So now I will provide the strap foundation and try to save or try to pass these both checks by providing the beam of strap foundation. Okay, so here you will click draw beam element. From here you will select your beam. You can define more beams, but I have defined only one beam, that will be 300 millimeter by 600 millimeter. I will click center point of one footing and take to the other footing center and press escape. Okay, now you can see in the 3D extrude view, here is a 3D. So here that's how the strap footing will be look like. Okay, you can also exceed this beam further to the end, but if for the designing of strap foundation, that will be okay if you move from the center to center. Okay, so now I have defined the beam. Now I will again run analysis and design. Okay, software has successfully done the analysis and design. Now I will check display, show deform shape against load combination, service load combination, apply. Let's see what are the deformation. Now the deformation is less than 25 millimeter. It means our deformation check is okay. Now check the show soil pressure against the service load combination, apply. Okay, so our soil pressure check is also okay, that is less than 200 kPa, so it's also going to okay. So we have successfully modeled the strap foundation. Now for the designing of footing reinforcement and beam reinforcement, the method of detailing is almost same as we have did in the previous lectures. So for the checking the results, before that we have to define the strip. Here I will manually draw the strips, draw design strips. For the X direction, if I draw the strip here, then the distance from the strip to the up and to the down means left and right of the strips. So here at the start and end of the strip. So here, for example, our footing width is 1.5 meter. So for both sides that will be 0.75 meter, 0.75 meter, which will make 1.5 meter. Okay, now I will just zoom the footing and click the start point, and okay, that's the one strip. Or in the x direction, for the y direction, same way. Okay, now I have defined the strips. Now I will run analysis and design. Okay, display show strip forces here. Now I will see the strip forces, for example, against the ultimate load combination. For example, moment, apply. For example, only in layer A, apply. Here strip forces show only in the slabs, mat, foundation, footings, etc. So here in the x, for in the x direction, layer A, for layer B in the y direction. Here is the moment value. Similarly for shear values. Wherever we define the strips, the software will give us the results. So here I have defined the two strips. Okay, now for the forces in the beam, in the strap beam, show beam forces. Okay, now for the, for example, major moment, for example, load combination, here we can see the moment values. Similarly, the major shear value, apply. Here is the major shear value. Okay, now if we want to see the beam design, and for example, first of all we see show beam design. Okay, longitudinal rebar reinforcement, apply. Here software will tell us how much top and bottom reinforcement is required. Okay, for example, if we impose the minimum criteria. Okay, now that's how we can see the strap foundation reinforcement details. For the slab detail, that is the same way as we did in the previous lectures. For example, apply, none, apply. That is basically, previously click this method, basically that is providing for the how much spacing is required in the x and y direction. For example, here that is, for example, 12 millimeter bar at 200 millimeter spacing top, and for bottom 12 millimeter bar at the rate of 200 millimeter center to center, apply. That is satisfying. For example, if we provide the 10 millimeter dia bar, apply, so it is not satisfying. So for example, either we have to reduce the spacing or increase the dia of bar. So it is up to you, you can play with that, apply. So that's how you can analyze and design the strap foundation in CSI SAFE software. So that's all. Have a nice day.